Here's example 1. Identify a point of continuity. The question says determine whether f of x equals 1 over 2x plus 1 is continuous at x equals to half. Justify using continuity test. What is the continuity test? Here is the continuity test. It says a function f of x is continuous at x equals to c. What is c? The number that they're giving you for x, whatever. Here it's half. If it satisfies the following conditions. I have 3 conditions that you have to consider that are very important. What are they? Number 1, f of x is defined at c. What do they mean by that? They mean if I substitute this x in the function is defined, or the function exists, or I don't get an error on the calculator or an undefined function. So the first thing, it has to be defined at whatever the x that they gave you. Number 2, I will ask myself, f of x approaches the same value from either side of c. So from numbers that are exactly less than half and numbers that are exactly more than half, because c is half in this question. Is the left side and the right side trying to approach the same number? If they do approach the same number, then I will say the limit as x approaches c of f of x exists. And we will see together with numbers. Number 3, the value that f of x approaches from each side of c, so point 2, the value that this, let's say these, they approach 2, is equal to the value of f of c. So if this is equal to 2, for example, this is also equal to 2. This is equal to 3. This is equal to 3. So any function that satisfies these 3 conditions is continuous. If it fails to satisfy any of these conditions, then you will say it is discontinuous. So basically, number 1, we will find f of c. Number 2, we will find the limit as x approaches c. Number 3, we will check if f of c is equal to the limit as x approaches c of f of x or no. If these 2 points are equal to each other or no. And this is called the continuity test. So the first step over here, what do you think I need to find if it's defined or no at c? And my c here is a half. So basically, I think I need to find f of half, right? So what will I do? I will substitute half in every x in the function. So what is 2 times half? It's 1. 1 plus 1 is 2. So f of half is equal to half, but that's by chance. Does f of half exist? Yes, it exists because f of half is equal to half. How did we find this? We found this by substituting half in the function. Okay, so the function is defined at x equals to half, and here we pass the first continuity test. We're going to the limit part. So the second continuity test says, does the limit as x approaches half of f of x exist? What does that mean? It will exist if the numbers from the left side equals to the number from the right side. I'll tell you what I'm talking about. We will construct a table that shows the values of f of x approaching from the left and from the right. From the left and from the right of what? From the left and from the right of half. How? Here is the table. You will place half in the middle. Okay, and then numbers that are getting close or very, very close to 0.5, but more than 0.5. So for example, 0.5001, 0.501, and 0.51. And here it's 0.4999, a number that is just smaller than 0.5. Why am I doing this? I'm doing this because maybe if I start with 0.49, I will not be as certain of my choice for the limit or my answer to the limit as if I'm using a number that is very, very close to 0.5. So 0.4999 is closer than 0.49, of course, to 0.5. And here are the f of x. How did I get these answers? By substituting in my function that was given in the previous slide. Substituting 0.50001, for example, in the x, and 01 in the x. And here And we got the y's. Here are the y's. Look at the pattern so you can say if the limit exists or it does not exist. Look at what? Look at the y's. Look at the blue lines. What are these numbers trying to approach? I think these people are trying to approach 0.5 or half, right? Like, this is the right side of 0.5. What about the left side of 0.5? Again, these people looks like they're getting closer and closer to 0.5, right? Yes, they also look. So what do I say? The limit exists or does not exist? It exists because the left side and the right side are trying to approach the same number. Remember, the answer for half was what? The answer for half was also half. So I'm trying to think with you about step number 3, that f of 0.5 is equal to the limit as x approaches half. Again, so what shall we say? Here it says the pattern of output suggests that as the value of x gets closer and closer to half from the left side and from the right side, f of x, what's happening to f of x is getting closer and closer to half. So we estimate that the limit as x equals half, the limit as x approaches half of f of x. What is f of x? This is the function 1 over 2x plus 1 is equal to half. So the limit does exist and it's equal to half. So what's next? My step number 3. Here, does the limit as x approaches half of f of x equal to half? What is this half? This half is f of half. I'm sorry, it's by chance that both of them are equal to half, but it happens. So f of 0.5, is it equal to the limit as x approaches half of f of x? Yes, they are equal, because here the limit was 0.5 in the previous slide, and here the limit and here the f of 0.5 is 0.5. So what do you think? It's a continuous function or no? It says, because limit as x approaches half of 1 over 2x plus 1 is estimated to be half, and f of half is equal to half, right? So these two are equal to each other, the limit and the f of 0, or the f of half, I'm sorry, are both equal to each other. So what do we conclude now? I bet you're thinking that the function is continuous. We conclude that f of x is continuous at x equals to half. If you want the graph to support this conclusion, here is the graph. What do you see the function as at x equals to half? Is it discontinuous? Is there any point discontinuity, infinite discontinuity? Is there any jump for the graph? No, the graph is continuous at x equals, let's say this is half. At x equals half, the graph is continuous and has an answer which is equal to half. I hope I made it clear for you. So here is the answer. Step number 1, f of half is equal to half. Step number 2, the limit as x approaches half of f of x exists. Step number 3, this limit as x approaches half of f of x is equal to half, so equal to f of half. Therefore, f of x is continuous at x equals to half. So here's a guided practice for you, example 1. The question says, determine whether the function f of x equals x squared plus 2x minus 3 is continuous at x equals to 1. Justify using the continuity test. Okay, just a general knowledge information or something that might help you for working on such questions. Any polynomial is continuous, and this is a polynomial. Any polynomial is continuous at any x. It doesn't have any points of discontinuity or any types of discontinuity because it's a polynomial. Like, I'm thinking, what number can I use for this x that will give me this function as undefined? This is impossible. So from the beginning, we know it is continuous, but we will need to prove it using the continuity test. And we will need to prove that it's continuous at x equals to 1. So what shall we do? First of all, we will think about the continuity test questions again, or points 1, 2, 3. The first one is f of x defined at c. Here my c is 1. Is f of x defined at f of 1? If so, check if f of 1 exists or no. My second test for continuity is f of x approaching the same value from each side of c? In simple, does the limit exist? Is the left side of the table equal to the right side of the table? And the last thing, the value of f of x, which you obtained from number 1, does it approach from each side of c, f of c? This means this f of c is the same as the limit. Is the number here the same as the limit? Let's move on and see what can we do about these three tests. Number 1, f of 1 is equal to 0. How did I know that? Remember the function in the previous slide? The function was f of x equals x squared plus 2x minus 3. So simply if we just substitute 0 here, or 1 here, and 1 here, I'm going to get 3, and 3 minus 3 is 0. This is how I got f of 1. And why did I get f of 1? Because they're asking me about the continuity at x equals to 1. So the first step, or the first test, the function is defined at x equals to 1. Number 2, construct a table that shows the values of f of x approaching from the left and from the right. And here I am testing the limit of the function. So the table is over here. I'm going to add 1 in the middle because this is my c here, and a couple of numbers greater than 1, exactly greater than 1, maybe 1.001, 1.01, 1.1, and 3 numbers less than 1, like for example 0.999, 0.99, 0.9. Where am I substituting these numbers? I'm going to substitute them in my function and see. First of all, I know that at 1, f of x is equal to 0, right? We should all know, of course, that these are the x's and these are the f of x, or the outcome of the function. Now, you need to use the calculator to get all the other values. So, one point I need to know what is happening from the right of 1 and from the left of 1, or what are the f of x's trying to approach. So 1.001, I'm going to get this number, 1.01, here's the number, and 1.1. Give yourself a second to observe what is happening. What number are these three trying to approach as I approach 1 on the x, as I approach 1 on the x? What is the y, or the f of x, trying to approach? Yes, it's trying to approach 0 because it's getting smaller and smaller and closer to 0. So I can see that the right side is trying to approach 0. What about the left side? The answers are, here are the answers. So it's getting smaller and smaller and negative. And you can try more numbers if you want, 0.9999999. You will find yourself getting closer and closer to 0. Every time you will be adding one more 0 here and one more 0 here, and it looks like these numbers from the left side are trying to approach 0. So does the limit exist? The limit of this function as x approaches 1 is 0, as you can see, and we proved it with the table. We did not just say that. So does the limit f of x as x approaches 1 equal to 0? Yes, I can see it is equal to 0. So now, what is this 0 that I wrote over here? It was f of 1, because the last step, if you remember in the table, we said we need to prove that 1 and 2 are equal to each other. So step number 1, f of 1 was equal to 0, as we saw. And step number 2, the limit as x approaches 1 of f of x is also equal to 0. So what did we conclude over here? Now we can conclude that f of x is continuous at x equals to 0.